We're going down this road to try to understand how animals behave out on the range. We talked about principles of behavior. Now we're going to talk about diet selection. How do animals know what to eat and what to avoid? We're going to talk about preferences and aversions. To be honest with you, when I went to school, we didn't know how animals did this. Now we have a pretty good idea of how animals make decisions and learn what is good and what is bad on the range. Before we begin talking too much about diet selection, we need to distinguish between two words, palatability and preference. Palatability is the attractiveness of a plant as forage. So we say plants are palatable because animals seem to like them. Preference is if you gave an animal a choice among foods, which one would they prefer? So most of our tests that I'll talk about today are based on preferences, even though we might talk about palatability. Both of these terms are related to flavor and post-ingestive feedback. In other words, they describe an interrelationship between flavor and feedback. How strong a preference is depends on the animal's physiological condition, because that affects whether it's when a plant is eaten, if it's highly positive or highly negative. Also, the food's characteristics, whether it has lots of fat or lots of toxins, will determine whether it's positive or negative. And then finally, the animal's experience with the food. We'll talk later about how animals change after they eat food, so their own experience with the food can change the feedback. So here's a couple principles. Palatability depends on feedback. Animals can detect positive feedback from nutrients and energy, and they can also detect negative feedback, such as those that are gained by anti-quality agents or secondary compounds. We talked about toxins that make animals sick, such as terpenes. So that would be an example of negative feedback. Animals distinguish between the good and bad foods because of these flavor and feedback interactions. So we're always going to be talking about how flavor is tied to feedback. Here, this model you've seen before, but we're going to now look at a few examples of how animals actually put this flavor feedback relationship together. They eat the plant and they taste it. That's where the flavor comes from. As the food enters their digestive system, it's digested and it either gives off positive feedback from nutrients and energy or negative feedback, such as secondary compounds that might make the animal ill. If the feedback is positive, animals form a preference for that food. They would choose it over others. If it's negative, they would form what we call an aversion. So then in the future, the animals would encounter a plant that made them sick and they would avoid it. In the future, if they had a food that made them feel better and they encountered it in the future, they would tend to choose it or seek it. Why does this work? The reason that there's a strong relationship between flavor and feedback is because animals are designed to link flavor from the mouth and the tongue to feedback in the digestive system. There's a whole lot of nerves that go between the mouth and up through the stem, the brain stem, and down to the gut. So there's a really good connection of communication between feedback and flavor. So animals detect these differences in food because they're built to do that. So we know that animals have preferences for some foods over another, and we also know that there's flavor and feedback relationships. But how does this work? Here was an experiment that was done in 1997. It was one of the first ones that really showed us a strong relationship between flavor and positive feedback. So Juan Villalba and Fred Provenza at Utah State University had 20 sheep, and they divided them into two groups. The first group on odd days would get onion flavored straw, and after they ate their straw, they would get gavaged with a bottle of water. So they would get water poured down a tube into their rumen. So it was delivered right into their rumen. Group 2 would eat oregano flavored straw, and then they'd get some feedback from water. So no energy. They'd eat the straw, it was pretty low quality, they didn't get any energy boost. On even days, they'd eat the alternate flavor of straw. So in group 1, they ate oregano flavored straw, and they would get a small bottle of starch water. So starch, which is a good soluble energy mixed with water, put down into their rumen. The group 2 would get onion flavored straw, and then they would get starch put into their rumen. So on odd days, they got no feedback, no positive feedback. On even days, they got a flavor with some positive feedback. And then the test was simple. They just gave the sheep a choice between onion flavored and oregano flavored straw. So which flavor do you think group 1 preferred? Well, based on what we've been talking about, it should be obvious. They would have preferred oregano flavored straw. Here's what the data looks like if you just look at the food that the animals got from where they got the starch. And so there was 8 days of training, and then on day 9, they were given a choice between oregano and onion flavored straw. And it didn't matter which the flavor was. The sheep always preferred the flavor of straw that was followed by starch feedback. About a week later, they had even stronger preference. In a month, they had really strong preference for whatever flavor of straw was followed by a feedback of a little starch boost. And what's interesting is that they continued this for quite a few weeks, and even 8 weeks later, they gave up the trial in 8 weeks, but there still was a strong preference for the flavor of straw that was tied to the starch, even though they had quit giving starch on day 8 of this trial. So the preference for a food that gave them a positive feedback was pretty long lasting. It was starting to wane, but still it lasted at least 8 weeks. So here's kind of hokey a video that was taken of these sheep when they were during training. So they've got 2 sets of sheep, again at Utah State University. One was fed straw with starch and one not. See what happens.
In this video, we see the importance of positive post-ingestive feedback when an animal is choosing which forages to eat. Both groups of hungry sheep are given straw to eat. This group nibbles a bit, but they are rather disinterested since straw is very low in nutrients. This group appears to love straw. The reason? Several days before, researchers poured a starch solution into their rumens each time they ate straw. Their experience is that eating straw results in positive consequences. Meanwhile, without any positive feedback, this group has mostly given up eating. While one group cleans its plate, the other group heads back to the shade.
So it's pretty clear from that video and from the previous research that sheep can form pretty strong preferences for straw as long as its consumption is followed by an energy boost. But I was curious at how that works because I know, for example, if I gave sheep a bowl of grain, like barley grain, it's full of starch. And also, if I gave them a choice between that and barley straw, they would prefer the grain over the straw because the grain has soluble carbohydrates, the straw has structural carbohydrates. And yet, if you took the total amount of energy in those two types of the parts of the plant, the grain and the straw, both have energy in them. So how does the animal know the difference? So my graduate student Liz Smith and I did an experiment here, and we thought maybe it had to do with how quick the feedback was. So we know that if you eat starch, if sheep eat starch, they get feedback pretty quickly. If they eat straw or structural carbohydrates, they get feedback, but it takes time for the microbes in the gut to ferment it, so it might take up to 8 hours before they'd start to get an energy boost from eating those structural carbohydrates. And then we also had a control, which was they ate the food and they just got water. These sheep were, it was one group of sheep, they were given 3 different flavors of straw, and one flavor was immediate feedback with starch given within 90 minutes of consumption. The other flavor that they ate was delayed feedback, so they ate the starch, they ate the food, the straw, and then they got starch infusion up to 8 hours later. And then the last one, they would get just a flavor that was paired with water. And we asked these sheep which flavor of straw they liked. And similar to Dr. Villalba's study, they preferred the food that gave the immediate feedback. They were really good at figuring out which food gave them the quickest feedback. So in test 4, 5, and 6, the first 3 were just they were getting used to it, and by test 4, 5, and 6, it was really clear. Didn't matter what flavor the straw was, they preferred the flavor that was associated with really quick feedback. Delayed feedback, the fermentable carbohydrates, they still liked it more than no feedback, but their stronger preference was for quick feedback. In this case, the amount of feedback was the same. The only thing that changed was the delay. Okay, now let's look at the other side of the coin. Now we know that animals form preferences for energy feedback, but why would they form aversions? So one of the early studies that was done by Beth Burritt and Fred Provenza at Utah State in the late 80s, Beth had 2 groups of sheep. She fed them mountain mahogany in pots, and mountain mahogany is a perfectly good plant for sheep. They like it. It's got lots of soluble carbohydrates in it because it's got nice big fleshy leaves, and it's a really palatable shrub. One of the groups, after they ate mountain mahogany, Beth gave them a gelatin capsule with some lithium chloride in it. Lithium chloride is a kind of salt, and one thing we know about lithium chloride is that it makes animals nauseous. We actually know this because lithium chloride used to be used as a behavior modification to treat depression, and animals and people that took this lithium chloride would get nauseous. I don't believe they use it anymore, but one of the side effects of lithium chloride is nauseous. So one group would get lithium chloride, which made them sick. The other group would just get an empty capsule when they ate mountain mahogany. And we would assume that the animals that got nauseous after eating mountain mahogany should go off of it. But how quick do you think that happened? It actually happened right away. The first day, day 1 of this trial, the sheep didn't care. Both sheep liked mountain mahogany, whether they were the control or the averted sheep. But after they ate the mountain mahogany, one group, as I mentioned, got lithium chloride, and by day 2, they were off of it. They cut their consumption radically. By day 3, almost none of those sheep even touched it. They even touched the mountain mahogany because they knew it was going to make them sick. And this lasted 4 or 5 days of the trial. Notice the control, every day of the trial, the sheep ate a little bit more. And that was because every time they ate it, they got some positive feedback. They got some energy from those fleshy leaves. So they were forming a preference for the food, while the ones that got lithium chloride were forming an aversion. One other thing that we know about preferences and aversions is that the magnitude matters. If you eat a food and you get a very strong positive feeling, you'll form a stronger preference for it, rather than if you just get a kind of a weak or moderate positive feedback. For example, celery is a good example. It isn't, it doesn't make you sick, but it's not much in it that really gives you an energy boost. So I don't know anyone that has a really strong preference for celery. It's a good ingredient, but I don't know anyone that has a strong preference for it because it doesn't give you very strong feedback. Unless, of course, you put like cheese or peanut butter on it, then you would get a stronger feedback. The same is true for aversions. If an animal eats a food, gets a strong negative feedback, they're going to form a strong aversion. In fact, it could be a lifelong aversion if it's a really strong feedback. So the amount of feedback affects the preference or the aversion that's formed. Here was a simple experiment that Johan du Toit did. Also, he was with the Utah State group at that time, and he looked to see if it was true that the stronger the feedback, the stronger the aversion. So he had 8 groups of sheep. He gave them a grain, and then after the grain, he gave them a capsule of lithium chloride to induce nausea. So one group, the control, got no lithium chloride, so apparently no nausea. Another group got maybe a little bit. Group 1, they really didn't avoid the grain. In the future, group 2 got some 2 grams, and then there was 3 grams, and then 5 grams and 8 grams. And one thing we know is that the animals that got really strong negative feedback, they really had low preference for the food that was associated with that aversion. So yes, it's true. The stronger the feedback, the stronger the aversion. So after seeing Johan du Toit's experiment, that got me thinking, because he showed that animals eat less of things that don't make them really sick, and they eat less of things that make them really sick, and they'll eat a little bit of things that make them a little sick. In other words, they don't just completely quit eating things that make them ill. And that makes sense because almost all the foods out in nature have some toxins of some sort of secondary compound in them. So if animals never ate any foods that made them sick, they'd probably starve because everything has a toxin in it. So I did an experiment to see if animals could vary how much they eat depending on the toxin concentration, which might explain how animals deal with toxic plants in the environment. So simple experiment, I had 3 sets of sheep. One set of sheep I gave 500 grams of oats with nothing on it, 0% of a toxin. The second group got oats, but it had 0.75% lithium chloride. So lithium chloride in this case was my plant toxin. The third group got oats, but it had twice as much lithium chloride. It had 1.5% lithium chloride. And then I measured the intake of oats over several days to see if animals could figure this out. Now, if everything is going right, the sheep with 1.5% lithium chloride should eat half as much oats as those with 0.75% lithium chloride, because if they did that, then they both would eat the same amount of toxin. So what happened? Well, actually, that's exactly what happened. The animals that where there was no lithium chloride, they ate all the oats they could, which was 500 grams. The animals that had the 0.75, they ate half as much oats as those that had 1.5% lithium chloride. So in the end, animals were really able to vary their intake depending on the toxin concentration, and in fact, they ate the same amount of lithium chloride. They just varied the amount of oats that they ate to accomplish that level. Now you'll see on days 6 and 7 that there was this kind of increase in oats and then a decrease. That probably had more to do with some barometric pressures and some changes in weather than anything else in the experiment. Just we know that by feeding animals, sometimes they just eat more than other days just because of weather conditions. So that's all that was happening there. So in other words, the bottom line is animals pretty sensitive and really able to vary the amount of food that they eat depending on the toxin concentration, assuming that they can figure out what that concentration is. So those are some really basic principles. We know that animals respond to feedback. Positive feedback gives preferences, negative feedback gives aversions. If you want to know a lot more, go ahead and take a look at the behave.net website. This is the a group that I'm a member of where we try to figure out a little bit about how animals behave in the environment. Some really good materials on that website.